Number 7, we have 3x plus 4 equals 13. Now remember, all these have been equations that were linear, and so we have a unique one here. We'll talk about that when we graph it. But for solving this, I was do minus 4 minus 4. This is going to be 3x is equal to 9 divided by 3 divided by 3. Turns out x is equal to 3. So like we saw before, for number 1 and number 4, we turned those into slope-intercept form equations. So this one's not going to be different. We will first have y equals 3x plus 4, but then we will also have y equals 13. And we'll talk about how that's going to be graphed in just a bit. But first of all, let's graph this one. So we have a slope, or a y-intercept of 4. So coming up here, 1, 2, 3, 4. And our slope is going to be a 3 over 1. So we have 1, 2, 3 over 1, 1, 2, 3 over 1. And that'd be what we have there for that. So let me go ahead and graph this. It's important when you make those sounds. You do that line. And also, for whenever y equals 13, this is kind of a unique equation. These are going to be where we have a 0 slope because the x is gone. So if I'm at 0, I'm going to get 13. That's going to be, let's see, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here, 1 is going to be 13, 2 is going to be 13, 3 is going to be 13, all those cases there. So when I would draw this line, you can see that the line connects at when we had x equaled 13. For 8, we have 3x plus 4 is going to be less than or equal to 13. And that exact same work came down. So we know we're going to have our x is going to be less than or equal to 3. And so in that case, comes through, what we would do is actually draw our number line. Have 0 and 3. And if you recall, because this is a closed, or this has the or equal to, it's going to be a closed circle. So it's going to be a circle that's closed, and because it's pointing that way, it'll go this direction. So number 9, 3x plus 4 is going to be greater than or equal to 13. Same work's going to come down. We've got our x and our 3, but this equation, or this inequality comes down that way. And we'll graph it, have a 0 and a 3, and this time, because it's going to be, again, or equal to, we have a closed circle, and it's pointing to the right. All right, part D. Francis recalls that he used number line graphs to show solutions of inequalities and moving straight ahead. For question C, part 8, he graphed the solution to the inequality 3x plus 4 is less than or equal to 13 on a number line shown here and below, which is what we did, just like that. Okay. He used a number line graph to show this, shown below to represent the solutions of inequality 3x plus 4 is just less than 13. The solution is going to be x is less than 3. And he has this here. So for part 1, how do the solutions of 3x plus 4 is less than or equal to 13 on a coordinate grid relate to the solutions on a number line? So based on that, we can see that the graphs on the number lines are exactly the same. They represent the same numbers, except because of that or equal to, on the top one, we fill that circle in and show that it includes the 3, where the other one is everything less than 3. All right, D2. Draw number line graphs to represent solutions of each inequality. Well, it's interesting that they would have us do this twice because we actually already did that one up here on number 2. So 2a and 2b, we already did those back here. So you can see those are the exact same ones. So this is D2a, which is here. We did that already. And D2b, we did that one already. So the only really change they want us to make is that in this case for D2c, we would do the exact same as this one right here, but it would end up being a closed circle instead. All right, let's take a look at the ACE work. For this assignment, you're doing numbers 1 through 3. All right, just like we had before with the security companies, we have 2 companies that are going to be car rentals. You have the information to work with there. In this case here, we have Mariana and Ming, and they're talking about their walking rates, and they give you all the information about how far they are away from school and how their average speed for walking, and writing some equations that would work with that. And in number 3, same process here. Supposing S and T are 2 numbers, that S is greater than T, determine whether each one is going to be true. So basically, you go through, are each of these true if S is greater than T? All right, guys. Have a good one. Let me know if you have any questions. We'll catch you next time.